Yes, we are going to start with chapter 11, section 9. Before starting section 9, we will discuss question number 20 from section 8. Here is question number 20 from section 8. Find the question is find the radius of convergence and interval of convergence sigma 1 to infinity. N varies from 1 to infinity, 2x minus 1 whole to the power of n divided by 5 to the power of n times square root of n. So an is equal to 2x minus 1 whole to the power of n divided by 5 to the power of n times square root of n. An plus 1, you replace n by n plus 1. So it becomes an plus 1 is equal to 2x minus 1 whole to the power of n plus 1 divided by 5 to the power of n plus 1 times square root of n plus 1. Therefore, an plus 1 over an is equal to 2x minus 1 to the power of n plus 1 divided by 5 to the power of n plus 1 times square root of n plus 1 times the reciprocal of an, because division by a fraction is the same as multiplication by its reciprocal. So times 5 to the power of n times square root of n divided by 2x minus 1 whole to the power of n. In the numerator, you have 2x minus 1 to the power of n plus 1. In the denominator, it is 2x minus 1 to the power of n. So the leftover will be 2x minus 1 to the power of n plus 1 minus n, which is 1. So that is a 2x minus 1. In the denominator, there is a 5 to the power of n plus 1. Numerator has a 5 to the power of n. So the leftover there is 5 to the 1, which is 5 in the denominator. And then under radical sign, you have n divided by square root of n divided by n plus 1. Therefore, limit n approaches infinity, absolute value of n plus 1 over n is equal to limit n approaches infinity, absolute value of 2x minus 1 over 5 times square root of n over n plus 1. And that is the same as limit n approaches infinity, absolute value of 2x minus 1 over 5 times square root of 1 over 1 plus 1 over n. And this, we have applied that method in several problems in this section and the previous section. So you are dividing both numerator and denominator by n. And now that limit is equal to absolute value of 2x minus 1 over 5, because 1 over infinity is 0. Square root of 1 over 1 is a 1. So the limit is absolute value of 2x minus 1 over 5. Limit n approaches infinity, absolute value of n plus 1 over n is less than 1 implies absolute value of 2x minus 1 over 5 is less than 1. Multiply both sides by a 5. You get absolute value of 2x minus 1 is less than 5. That means negative 5 less than 2x minus 1 less than 5. Intermediate algebra topic. Add a 1 on both all three terms, you get negative 4 less than 2x less than 6. Divide both sides by 2, you get negative 2 less than x less than 3. It is not a 6. That was a confusion when we discussed it in the previous section. Okay, so negative 2 less than x less than 3. And now you are checking the endpoints. At x is equal to negative 2. 2x minus 1 is 2 times negative 2 minus 1. That is 2, negative 4 minus 1, negative 5. Its absolute value is negative 5. So it is negative 5 to the power of n. Now we are not taking the absolute value. So an is equal to negative 5 to the power of n divided by 5 to the power of n, here is the formula, n. You are using this formula. So 2 times negative 2, which is negative 4, minus 1 is negative 5 to the power of 5 divided by 5 to the power, negative 5 to the power of n divided by 5 to the power of n times square root of n. And that is equal to negative 1 to the power of n times 5 to the power of n over 5 to the power of n times square root of n. 5 to the power of n cancels. You get negative 1 to the power of n divided by square root of n. So sigma an is equal to sigma negative 1 to the power of n over square root of n is a convergent series because limit of Vn, that is limit n approaches infinity, 1 over square root of n is 0 and 1 over square root of n plus 1, that is Bn plus 1, is less than Bn. So it is a decreasing sequence and the limit is 0. So it is convergent when x is equal to negative 2. At x is equal to 3, an is again 5 to the power, replace x by 3, 2 3s are 6. 6 minus 1 is 5, so it is a 5 to the power of n in the numerator. 5 to the power of n times square root of n in the denominator, that is 1 over n to the power of 1 over square root of n, that is 1 over n to the power of 1 half. Therefore, sigma an is sigma 1 over n to the power of 1 half. This series is divergent because of the p-test. So, p is 1 half, which is less than 1. Therefore, the series is not convergent when x is equal to 3. Therefore, the interval of convergence is negative 2 less than or equal to x less than 3, or semi-open interval negative 2 to 3, including negative 2 and excluding 3. And the radius of convergence is 1 half of this interval, 3 minus minus 2, that is 5. So total length of that interval is 5. 5 divided by 2 is the radius of convergence. Okay, so please practice it. Now we are going to start with the 11.9. 11.9 deals with the representation of a function as a power series. Okay, we start with a very common series. This is a geometric series with the first term is equal to 1 and common ratio is x. So that is a 1 plus x squared plus x cubed plus etc. So that is the same as sigma n varies from 0 to infinity x to the power of n. When n is 0, it is x to the 0, which is 1. When n is 1, it is x to the 1, which is x, and so on. So sum of a geometric series is a over 1 minus r, which is 1 over 1 minus x. Of course, the result is true only when x lies between negative 1 and 1. And this function may be used to find the power series representation of similar functions. So here 1 over 1 minus x is equal to 1 plus x squared plus x cubed plus etc. So by differentiating and integrating this function, we get different power series. 1. Replace x by negative x. So if you replace x by negative x, it becomes 1 over 1 plus x. 1 over 1 minus x. 1 over 1 plus x is equal to 1 minus x plus negative x the whole square, which is the same as x squared minus x cubed plus x to negative x to the power of 4, which is the same as x to the 4. So all the even power terms are positive and odd power terms are negative. So that is integral sigma n varies from 0 to infinity, -1 to the power of n minus, it must be -1 to the power of n, it must be n, -1 to the power of n, x to the power of n. Otherwise, yeah. It must be -1 to the power of n, not n minus 1. 1 over 1 plus x. But this series is more easy to understand. 1 minus x plus x squared minus x cubed plus etc. That is equal to 1 over 1 plus x. Okay, replace x by x squared. We get 1 plus x squared plus x to the 4 plus x to the 6, etc. is equal to 1 over 1 minus x squared is the same as sigma 0 to infinity x to the power of 2n. Replacing x by negative x square, you get 1 over 1 plus x square is equal to 1 minus x square, alternatively positive and negative. Now 1 minus x square plus x to the 4 minus x to the 6, etc. That is integral, sigma 0 to infinity, -1 to the power of n, x to the power of 2n. The power series representation of other functions may be obtained by differentiating or integrating 1, 2, 3, or 4 once or more than once. First one, differentiate 1 means the first equation with respect to x. Differentiate the first one, this equation with respect to ex. So we are going to, this is second term. This is one. So differentiate this with respect to x. You get -1 over 1 minus x the whole square times -1. This is derivative of 1 over x is -1 over x square. So this is -1 over 1 minus x. The whole square times -1 because this is a negative x. So that is the chain rule. Two negatives makes a positive. That means 1 over 1 minus x the whole square. Differentiate the right side. That is, you get derivative of x is 1. Derivative of x square is 2x and so on. So 1 over 1 minus x the whole square is equal to 1 plus 2x plus 3x squared plus 4x cubed plus etc. And the sigma notation is given here 1 to infinity n times x to the n minus 1. Integrating to second one with respect to x, we get integral of 1 over 1 plus x square dx, which is equal to tan inverse x plus c. Now integrate the right side, apply the power rule, is going to be 0 to infinity, -1 to the power of n, x to the power of 2n plus 1 over 2n plus 1. See, integrating 2. So this is the second result. No, integrating 3. 3 is 1 over 1 plus x squared. So you integrate this, you get tan inverse x plus c is the left side. Right side, when you integrate this, integral 0 to infinity, -1 to the power of n, x to the 2n plus 1 over 2n plus 1. That is the power rule. So integrating 3, it is not 2. And tan inverse x, so tan inverse x is equal to x over 1, or here itself you substitute x is equal to 0. If x is equal to 0, you get tan inverse 0 plus c is equal to this series, and c is, therefore c is 0. Tan inverse 0 is 0. 0 is equal to that series plus c means c is equal to 0. You just plug in c there. So tan inverse x is equal to x over 1 minus x cubed over 3 plus x to the 5 over 5 minus x to the 7 over 7 minus etc. So that is the series expansion, power series expansion for tan inverse x. In particular, you substitute x is equal to 1. When you substitute x is equal to 1, tan inverse 1 is pi over 4. So series for pi over 4. Right side, 1 minus 1 third, 1 cubed is 1. 1 third plus 1 over 5 minus 1 over 7, etc. This is the value of pi over 4. So pi is equal to 4 times the whole expression. So you have the expansion for pi 4 times 1 minus 1 over 3 plus 1 over 5 minus 1 over 7 plus etc. So that is an infinite series representing the irrational number pi. And this is a question from textbook. Number 4. Fx is equal to 1 over 1 minus 4x square. We know 1 over 1 minus x is 1 plus x square plus etc. That is the basic series, which is sigma 0 to infinity x to the power of n. Now you replace it, here the interval of convergence is absolute value of x less than 1. Therefore, 5 times 1 over 1 minus x square is going to be 5 times sigma 0 to infinity 4x square. So instead of x, you have 4x square. You replace x by 4x square. So sigma 0 to infinity 4x square to the power of n, and that is 5 times integral 0 to infinity 4 to the power of n x to the power of 2n, and that is the expansion for fx. So this is the power series expansion for fx. Now the 4x square, absolute value of 4x square must be less than 1, because for the basic function here, absolute value of x must be less than 1. So you replace x by 4x square. So absolute value of 4x square must be less than 1. That is x square. Absolute value of x square must be less than 1/4. That is absolute value of x must be less than 1/2. So x lies between negative 1/2 and positive 1/2. So that is the interval of convergence. And then radius of convergence is 1/2. Next, number 6. Fx is equal to 4 divided by 2x plus 3. Factor out it. Oh, it must be 3x plus 2. No, sorry, 2x plus 3. You are yes, you pull out a 3. 3 divided by 3 is 1. 2x divided by 3. So, or you expand this, 3 times 1 is 3. 3 times 2x over 3 is 2x. Just we switched the 2 terms. So that is equal to 4 divided by 3 times 1 plus 2x plus 3. This is 4 over 3 times sigma 0 to infinity negative 1 to the power of n 2x over 3 to the power of n. You replace x by 2x plus 3. That's it. So in result number 2, you replace x by 2x over 3. Where is result number 2? Result number 2 is here. Sigma 0 to infinity. No, it's not. Result number 2, it is here. So sigma 0 to infinity negative 1 to the power of n minus 1 times x to the n. So there you replace x by 2x minus 2x over 3. So that becomes 4 over 3 times sigma 0 to infinity negative 1 to the power of n 2x over 3 to the power of n, and that is equal to sigma 0 to infinity negative 1 to the power of n 4 over 3 times 2 to the power of n divided by 3 to the power of n times x to the n, and that is equal to 4 is the same as 2 square. So numerator you have 2 to the power of n plus 2. Denominator there is a 3, so it is 3 to the power of n plus 1, x to the power of n. So that is the power series expansion for the given function. And now the interval of convergence, absolute value of 2x minus 3. Here x is replaced by 2x minus 3. Absolute value of 2x minus 3 is less than 1. So absolute value of x is less than 3 over 2. And that means negative 3 over 2 less than x less than 3 over 2. Number 8, x divided by 2x square plus 1. So x divided by 1, you write it as x divided by 1 plus 2x square. So that is x times the expansion of 1 over 1 plus 2x square is 0 to infinity, negative 1 to the power of n, x to the power of n, replace x by 2x square. You replace x by 2x square. And that is now multiply each term by x, you get 0 to infinity, negative 1 to the power of n, 2 to the power of n, x to the power of 2n multiplied by x, that is x to the power of 2n plus 1. So this is negative 1 to the power of n, 2 to the power of n, x to the power of 2n, 2 times n, times x. That means x to the power of 2n plus 1. Now the interval of convergence, absolute value of 2x squared. So this expression, you replaced x by 2x squared. Absolute value of 2x squared is less than 1. That is x squared is less than 1/2. That is absolute value of x is less than 1 over square root of 2. Means interval of convergence is from negative 1 over square root of 2 to positive 1 over square root of 2. You don't have to worry about rationalizing the denominator. Just leave it as the answer. Number 10. Fx is equal to x plus a over x squared plus a squared. So you split it into 2. That is x over x squared plus a squared plus a over x squared plus a squared. From the denominator, you pull out an a squared. So that becomes, denominator becomes a squared times 1 plus x squared over a squared. A squared is pulled out. So a squared times 1 plus x squared over a squared. You can verify it by distributing that a square. A square times 1 plus is a square. A square times x square over a square is x square. So the denominator is written as a square times 1 plus x square over a square for both the terms. And so for the first case, it is x over a square is there. Then you write the expansion of using the formula for 1 over 1 plus x. So that is integral. Not integral, sigma 0 to infinity, negative 1 to the power of n, x to the power of n, replace x by x square over a square. Second term, a divided by a square, that is 1 over a, times sigma, n varies from 0 to infinity, negative 1 to the power of n, x square over a square to the power of n. That is the result number 2. Yes. So that is equal to sigma. You multiply this, you get sigma negative 1 to the power of n, x to the power of 2n plus 1. Here there is 1x. So it becomes 2n plus 1, a to the denominator, a to the power of 2n plus 2n from this, and there is a square. So it is 2n plus 2 plus the second term, sigma 0 to infinity, negative 1 to the power of n, x square to the power of n means x to the 2n divided by a to the 2n plus 1. And if you want, you may write it as a single sub sigma notation. And here, it is not necessary, just leave it. Interval of convergence, you replaced x by x square over a square. So absolute value of x square over a square must be less than 1. That is, absolute value of x square must be less than a square by multiplying both sides by a square. That is, absolute value of x must be less than a. x lies between negative a and positive a. So interval of convergence is negative a to positive a. Question number 12. Fx is equal to 2x plus 3 divided by x squared plus 3x plus 2. So that is equal to 2x plus 3 divided by x squared plus 3x plus 2. You decompose it into partial fractions. Factor the denominator first. Denominator is x plus 1 times x plus 2. So it becomes 2x plus 3 divided by x plus 1 times x plus 2, which is equal to a divided by the first factor plus b divided by the second factor. Now multiply all the three numerators by LCD x plus 1 times x plus 2. First x plus 1 and x plus 2 cancels, leaving it to x plus 3 in the left side. Second term, first term in the right side, x plus 1 cancels, a times x plus 2. The last term, x plus 2 cancels, b times x plus 1. And that is, you distribute ax plus 2a plus bx plus b, combine like terms. So 2x plus 3 is equal to a plus b times x plus 2a plus b. And so a plus b is equal to 2. This is coefficient of x. 2a plus b is equal to 3. You subtract. You may solve the system by your own choice. What I did here is I subtracted first equation from the second. So 2a minus a is a. B cancels. 3 minus 2 is 1. So a is 1. A plus b is equal to 2 means b also must be equal to 1. Therefore, 2x plus 3 divided by x square minus plus 3x plus 2 is equal to a over x plus 1, means 1 over x plus 1 plus 1 over x plus 2. And we are using the same procedure here. 1 over x plus 1 is the same as 1 over 1 plus x. That is same as integral 0 to infinity negative 1 to the power of n x to the power of n. So you refer result number 2 there. And we know the interval of convergence is negative 1 to 1. And then 1 over x plus 2, as in the previous case, previous problems, you pull out a 2 times 1 plus x over 2. And this 1/2 will stay there. So 1/2 times sigma. N varies from 0 to infinity, negative 1 to the power of n, x over 2 to the power of n. X must be replaced by x over 2. X over 2, the whole to the power of n is x to the n over 2 to the n. And interval of convergence, x over 2, absolute value of x over 2 must be less than 1. This is for the second one. For the first term, interval of convergence is from negative 1 to 1. We are finding the interval of convergence for the second expression. So you replace x by x over 2. So absolute value of x over 2 must be less than 1. That is, absolute value of x must be less than or equal to 2. Multiply both sides by a 2. That means x lies between negative 2 and 2. So for the first one, x must lie between negative 1 and 1. Second one, it must lie between negative 2 and 2. So which one do you pick? This is the strategy. You draw a number line and mark both the intervals, negative 1 to 1, shade it, negative 2 to 2, shade it, and now you pick the double shaded part. This is the best way to work out. So draw a number line, shade the first interval, negative 1 to 1, then you shade the second interval, negative 2 to 2, and a double shading part, double shaded part. So negative 1 to 1 is the interval of convergence, and here I have written as a single summation. You may leave it as a leave it in this line or this line. So here sigma, just like a pulling out common factor, it is not actually pulling out common factor. So sigma n varies from 0 to infinity, negative 1 to the power of n is common, x to the n is common. You have to write x to the n also here. So negative 1 to the power of n, then x to the n is missing here. You must write x to the n. times 1 plus 1 over 2n plus 1, or you may leave the answer in this line. Then number 16. This is tan x squared times, function is x squared times tan inverse x cubed. You have to expand it as a power series and you find the radius of convergence. We know 1 over 1 plus x squared, we have seen this. 1 over 1 plus x squared is integral, no, sigma 0 to infinity, negative 1 to the power of n, x squared to the power of n. We have seen this on the first page of this document. That is equal to sigma 0 to infinity, negative 1 to the power of n times x to the power of 2n. Integrate both sides with respect to x, we get tan inverse x plus c. That is integral of 1 over 1 plus x squared is tan inverse x plus c is equal to sigma 0 to infinity, negative 1 to the power of n, x to the power of 2n plus 1 over 2n plus 1. You don't have to write a plus c on every term. One c will take care of everything. And when x is equal to 0, tan inverse 0 is 0 plus c, right side is 0. And so c is equal to 0. Yeah, right side first term is negative 1 to the power of 0, that is 1, x to the 1. So there is an x on every term. So tan inverse 0 plus c is equal to 0 means 0 plus c is equal to 0, which is c is 0. Therefore, tan inverse x is equal to sigma 0 to infinity, negative 1 to the power of n, x to the power of 2n plus 1 divided by 2n plus 1. And now multiply both sides by x square. You get x square times tan inverse x cubed is equal to x square times sigma 0 to infinity, negative 1 to the power of n, x cubed. This is x cubed. And whereas we started with a tan inverse x. So this is tan inverse x cubed. So you have to replace x by x cubed. X cubed to the power of 2n plus 1 divided by 2n plus 1. You replace x by x cubed. Why? Because this is for tan inverse x. So if you want the expansion of tan inverse x cubed, you must replace x by x cubed. So x squared times sigma 0 to infinity, negative 1 to the power of n, x cubed to the power of 2n plus 1 over 2n plus 1. That is x squared times sigma 0 to infinity, negative 1 to the power of n, x to the power of 3 times 2n plus 1. That is 6n plus 3. 3 times 2n plus 1. 6n plus 3 divided by 2n plus 1. And that now multiply by x square. You get 6n plus 3 plus 2 because x to the 2 is there. So it becomes x to the power of 6n plus 5. Sigma n varies from 0 to infinity, negative 1 to the power of n, x to the power of 6n plus 5 divided by 2n plus 1. Now the radius of convergence, you have replaced x cubed by x cubed. So absolute value of x cubed must be less than 1. That implies absolute value of x must be less than 1. That means the radius of convergence is 1. And interval of convergence is negative 1 to 1. Okay, so I think that's it. Yeah. Okay, we'll discuss the last section, that is 11.10th section of chapter 11 later.